Hi everyone. I'm doing some experiments with this test device, which is just a bicycle wheel that I have two different inductors on it. I have a base inductor here with a steel lamination core and another steel lamination core with another inductor, but I'm not going to be using this top one. That's for other things. The experiment here that I'm doing is looking at flyback. I'm just doing experiments with flyback, and these are experiments that I've done in the past, but not quite in this kind of configuration. This is more like observing what's going on in a motor action, and as far as putting a pulse into a coil and seeing the movement. Now, what pointed out previously in the past, what's interesting is when you put a diode across your coil here and the reverse polarity of what the current would be going in. So the yellow alligator clip here is my positive and this is my negative, the green one. And I have a little pulse circuit here that I have a very small pulse with very small pulse width. So, and I'm putting in high voltage. I have, 5 batteries there, and in series, and they're all 12-volt batteries. So I have a total voltage potential here of 62.5 volts. And what I'll do is I will just momentarily contact the positive here, because my switch, I can't get lower than 4 hertz, the frequency. So I just basically give it one pulse just by touching it, and hopefully it'll land in the right spot, I mean, as far as pulse is concerned. So what I want to show is the amount of movement that's going to happen. And I'm just going to position the camera here, and I'm going to give that one pulse. And here we go. So that was the pulse. Hardly any movement whatsoever. And this is the, sorry about the light there. This is the scope shot. I'm going to post that in the forum topic, and you'll be able to see all the data, the time division and, you know, voltage divisions and all that. But you can see here, this is our pulse here, really short. Right now we're on a, actually I can brighten that up. Let me see here. I don't know if that'll help. Okay, so right now I'm on a very small time division. It's basically 4 microseconds. And we're maxed out here as far as the voltage, because I'm trying to show the full flyback, full voltage flyback. So the probe's on times 10, or x10 if you want, 100 volts division there. So every square is 100 volts, and if we look, our flyback goes pretty close to the 600 volt range. And our voltage peak to peak is there, 639. But we have this upper part here, which is a total of, you know, somewhere around 62 volts is the battery potential there. So that's the pulse that happens, and you saw the movement is next to none. And I'll give you just one more view of that motion, that movement for that pulse. So that's all what it gave there. So now what I'm going to do is I've got a little switch here. I've got a diode across here. That's a 800 volt diode. And now I just engage it by flicking that switch. And we're going to do the same pulse. So basically our input current is going to be identical, because it's just basically that pulse. But what's going to change here is our flyback will not be there. It'll basically be close to shorted across. So what I'm going to do is change my my voltage divisions down to 2 volts. And we'll be able to see what happens with the flyback. Of course, our pulse is going to be off scale, and that's why, you know, I've positioned my zero line here basically up here, because I wanted to be able to show the whole flyback. So now I'm going to do the same pulse, and we're going to look at what the result is. So here goes, and getting a view of that, and now we're going to see what movement we got. So we got probably about ½ an inch movement with that pulse there. And what I'll do is I'll stop it again and give you another view of it here. And here goes. So obviously now you see we're not putting any more energy, we're just using the flyback kind of shorted into the coil. One more time. So there you go. You see the huge difference, and without any more input. So there is our, our same pulse, but now remember our voltage division is really sensitive now. We're on the 2-volt division, so every square there is 2 volts. And now you can see here the flyback is actually obviously going in the opposite direction, the voltage. Now that's with the probe across the coil there. And it is now really extended. So this duration of time holding at around, well, I guess it's switching at around 0.7 volts around that range. No, actually over 1 volt here, because that's 2 volts. So it's switching around 1 volt. And I guess shutting off around, I don't know, maybe 0.7 volts, 0.5 volts. So that's what it looks like, and that is the difference. And basically my question is, why is it doing this different behavior? Is it because the voltage is capable, the flyback voltage is capable of maintaining the magnetic field longer? What's going on? That's basically my question. I'd like to have everybody's input on that. And the idea is, obviously inductors are voltage devices, and I'm thinking, well, if it's a voltage device, give it voltage. Why are we trying to put current in inductors? Why don't we just go for higher voltage and shorten the pulse make a very small pulse and use a much higher voltage, and then we can use the flyback and get it to do work for us. So that's what I'm kind of seeing here, and I'm trying to get the reasoning why we are not doing that or not looking into that. And I'd like to hear everybody's opinion on that. So that's what I'm, doing here right now, and I like to, like I say, get your opinion on that. And the other thing I'll do is I've got a 0.1 ohm shunt here, and I'll do a scope shot of both ways, but I can assure you there's zero difference in each pulse, with the flyback diode or without. But I'll do them anyways, and I'll post those shots. So I won't do them in this video, it would just get too long. I think you've got the idea, and thanks for watching. Bye now.